Hello, I'm Jamila Jamilova, Startup Solutions Architect at AWS. I've been at AWS just under 3 years, working with high priority and emerging startups in the UK and Ireland. At AWS, there are various types of solutions architects, and I'm currently a startup solutions architect. I help startups to build on AWS, to build their first product, which will become next big unicorn. Let's get started with today's session about choosing the right database for your startup. Let's have a look at our agenda. What is a purpose-built database? Why do we need purpose-built databases? What are the AWS purpose-built databases and what are the options? And then, last but not least, we will have a look at Let's Build a Bookstore app. Before we start talking about the portfolio of purpose-built databases that are available on AWS, let's talk a little bit about what even is a purpose-built database and why do we need them. What we are seeing on the slide could be a monolithic application where all different components are part of the same application. And this is okay. Some customers need to build their product as fast as possible, especially startups, and minimize their time to market. So you probably made some choices based on what the team is familiar with and can quickly get started on. However, over time, you may realize that the design is imposing some limitations, such as ability to choose the right programming language for the right job. Although different modules may have different scalability requirements, you are forced to scale the whole application. Also, compute and memory requirements. And this is also the case when you choose a database for your product. Different requirements or use cases may require different databases, and however, you need to solve them with the database that you decided to go with. When the monolith becomes challenging to manage and maintain, then what we've seen in our customers is that they break the monolithic application down and they start to move to a microservices architecture where potentially each component is implemented by a different service, but they all still work against a single database. So, what are some challenges that with one-size-fits-all database can happen? First, scaling. While monolithic architecture seems like a good idea to quickly get the application started, over time you may encounter some limitations that you should be aware of right at the start of building your startup. First is scaling limitations. Having monolithic database for multiple services creates a tight coupling and the inability to deploy service changes independently if there are multiple services accessing the same database. Think about peak events. Combining multiple services into a monolithic database would mean you will grow beyond what a single database or server can deliver. So you will start thinking about horizontally scaling, sharding, which has its own complexities. The next, availability challenges. Need similar configuration for all services for highly available replication. Security upgrade will require some downtime and larger blast radius. And last but not least, high operations. Your engineers will need to invest time in patching, upgrading, and managing the infrastructure. So what does decoupling your data means? It typically means evolving from monolithic and tightly coupled architecture into microservices and decoupled architecture. Each microservice exposes an API application, which is discoverable and can be used in a self-serve manner. In addition, each microservice has an independent lifecycle, which means that each one can be developed, deployed, scaled, and managed independently. Breaking complex applications into small pieces and then picking the best tool to solve each problem. The best tool for a job usually differs by use case. Need to evaluate different technical aspects of each module, such as workload is going to be transactional or analytical. Do we need to enforce relationship among different entities? What is the required throughput and latency? What about the access patterns? What about the consistency? Do we need an eventual consistency or strong one? Well, let's work backwards from your requirements and let's have a look what are the AWS purpose-built databases out there. So I'd like to introduce you the Bookstore app and its main functionalities. So on the corner, you see a QR code and the URL that you can type and actually see the Bookstore app in action as a workshop. You will be able to see the full architecture, all the nitty-gritty parts, and even deploy on your AWS environment. So the goal of the AWS Bookstore demo app is to provide a fully functional web application that utilizes multiple purpose-built AWS databases. Increasingly, modern web applications are built using a multitude of different databases. Developers break their large applications into individual components and select the best database for each job. Modern applications have a diverse set of access patterns, and the requirements imposed by those access patterns will determine which database can best serve those requirements. So, as an example, you see on the screen that Bookstore app has several components. For example, search, bookstore bestsellers, cookbooks, recommendations for books, etc. And we will see in action which databases will be applicable for each component. So we want to focus on using different data stores in a single app. We will primarily look at 4 user experiences: customers searching for the book they want, bookstore bestsellers, cookbooks, details about the book, and 4, recommendations for books based on the books your friends have bought. So let's start with the front end. There is React web application, CloudFront, and Amazon S3 to globally distributed. Web application assets are stored and maintained in Amazon S3, like book cover photos, JavaScript file, style sheets, etc. Amazon CloudFront caches the front-end content from Amazon S3 and distributing it globally. The front-end interacts with Amazon Cognito and Amazon API Gateway only. So you may think why we're using Cognito? It's for authentication requests. Amazon CloudFront, our content delivery network to deliver content securely with low latency. Amazon S3 for object storage to store and retrieve data from anywhere. And the Cognito, a service to implement customer identity and access management system that is secure and scalable. We start with the design of the backend. What are the resources that we need to provide basic book catalog and checkout functionality? Let's chop it down into pieces. We have books, we have carts that books are added to, and we have checkout to place an order with books currently on the cart. We will use API Gateway as the front door to have front-end clients interacting with the functionality and business logic of our backend. Amazon API Gateway is fully managed service that makes it easy for developers to create, publish, maintain, monitor, and secure APIs at any scale. It handles all the tasks involved in accepting and processing up to hundreds of thousands of concurrent API calls. So, based on the requirements, we come up with the endpoints that help us implementing the desired functionalities. We're going to use AWS Lambda, our service to run code without thinking about servers or clusters. The unit of the service is a function where we will code the business logic for each endpoint. This function will be invoked by API Gateway upon HTTP requests. But so far, we still don't know which database we should be using. We just know we need a database to store book, card, and order information. Well, before choosing which database you actually need to use for each component, you need to understand what type of data you will be using for the database. For example, if you have structured data, you may benefit from using Amazon RDS, which provides a management and automation layer around database engines that takes care of activities such as provisioning, configuration, patching, backups, or monitoring the health of database. Within this management framework, we offer the widest variety of database engines, with 2 popular commercial engines, Microsoft SQL Server and Oracle, and 3 popular open source database engines, such as MySQL, PostgreSQL, and MariaDB. Additionally, it offers cloud-native relational database solution, Amazon Aurora. And here you also see the benefits of each database engines used by Amazon RDS, such as easy to administer, available and durable, highly scalable, and fast and secure. But if you have unstructured or semi-structured data, then you may benefit from Amazon DynamoDB, which is a fully managed, serverless, key-value, NoSQL database that delivers a single-digit millisecond performance at any scale. DynamoDB has the ability to group records together by a related key and sort them by one of the attributes in the records. This makes it the perfect data store for access patterns that have relatively simple lookup requirements, like getting a specific book, user, or order record, and that is how we use it in the Bookstore app. Right. Another requirement. We would like to display to our users what books we are selling the most, our bestsellers, top 20 purchased or rated books. We want to create a leaderboard. With the rise of real-time applications, in-memory databases are growing in popularity. In-memory databases predominantly rely on main memory for data storage, management, and manipulation. Amazon ElastiCache makes it easy to set up, manage, and scale an in-memory data store or cache environment. It also works with both the Redis and Memcached engines. Let's go back to our architecture. Here we see the bestsellers list. Amazon ElastiCache for Redis reads order information from Amazon DynamoDB streams, creating a leaderboard of the top 20 purchased or rated books. What if we wanted to display book recommendations based on what our friends in the platform have bought? Well, Amazon Neptune is a fully managed database service built for the cloud that makes it easier to build and run graph applications. It's designed to efficiently access data that is highly related, where data modeled as a graph. You can use the OpenGremlin and SparkQL query languages to access the data. It is high-performance database, allowing you to query billions of relationships with millisecond latency. Amazon Neptune provides social recommendations based on what users' friends have purchased, scaling as the storefront grows with more products, pages, and users. Well, what about search? Amazon OpenSearch Service enables full text search for our storefront, enabling users to find products based on a variety of terms, including author, title, and category. So you need to use the right database for the right job. Previously, we covered some of these databases, like relational database, we covered DynamoDB, we covered in-memory database. You can read up about graph database as well. But what about the other use cases? For example, Amazon DocumentDB is a fully managed native JSON document database that makes it easy and cost-effective to operate critical document workloads at virtually any scale without managing infrastructure. It simplifies your architecture by providing built-in security, best practices, continuous backups, and native integrations with other AWS services. Amazon TimeStream, which is a fast, scalable, and serverless time series database. With Amazon QLDB, which is Quantum Ledger Database, you can maintain an immutable, cryptographically verifiable log of data changes. It's immutable and transparent journal. Amazon Keyspaces, Key Value Database. It's a serverless, scalable, highly available, and managed Apache Cassandra compatible database service. If you want to read more and learn more about AWS database services, please use this link as shown on the screen. Thank you.